Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the differentiation rules in computing the derivative of this given function. So this is on the application of the rules of differentiation in computing the derivative of specific functions. This is another example for algebraic functions or terms that will use the idea of the first three proven differentiation rules. I purposely inserted this before proceeding to another rules of differentiation so that you could actually look into the appropriate implications of what I've learned. We are going to find the first derivative or differentiate this given function here. F of x is equal to 7 over x to the power of 8. Okay, so this is not a rational function, so we cannot use here. Probably you're thinking of the quotient rule, but no, this can actually be written using the loss of exponent as 7 x to the power of negative 8, right? As you have a algebraic expression on our denominator, you can always bring that up, but making sure that the exponent is negative now. Hence, we are going to use here two of those differentiation rules we have proven already. We are going to use here the constant multiple because we can separate this. We have here the constant, and f of x is the multiple of that. Say, you have here g of x is x to the power of negative 8, and you can use that. And of course, by solving for this, you're going to use here the differentiation rule for a power. So we have two different rules that we are going to apply here: the rule for differentiating a constant multiple and differentiating a power. So the first derivative of this, or as we differentiate that using the rule for constant multiple, we are going to have here 7 times the first derivative of this function. Okay, that's the rule for constant or scalar multiple. But this is that actually. And by solving g prime of x, we are going to use here the rule for a power. Take note, I'm just blurting out the rules so that you will be able to look for the implications of proving them first before applying them to a specific situation. So with this, using the power as n being negative 8, so you have here n times x to the power of n minus 1. Hence, your g prime of x is negative 8x to the power of negative 9. You can return the negative exponent later or from here, but I just automatically multiply them. So we have here 7 times negative 8x to the power of negative 9. Okay? Therefore, you will have here negative 56x to the power of negative 9. Or since we don't want negative exponents, you will have here your first derivative is negative 56 over x to the power of positive 9 as you move down the entire expression with negative exponent. So this is the result using two of those proven differentiated rules. We have the constant multiple here, and this is for the power. For some who are already familiar with showing this result, of course, you can automatically say for f of x being this, you can simply automatically attack it in this manner. If you can, you will have here 7 times negative 8 x to the power of negative 8 minus 1. Okay, with attacking it as 1, so you will have here negative 56 x to the power of negative 9. So you still have here negative 56 over x to the power of positive 9. We'll have the same result. This is faster as soon as you are already familiar with all the processes, but this process earlier presented is by showing the implication of the proven rules. Both are still acceptable. Thank you very much for watching. So what are you waiting for? Subscribe now.